Hello and welcome to Module 2 of the ESPT training. Module 2 will cover selection of minimum essential indicators, which is important when resources are limited. There are 3 learning objectives for Module 2. By the end of this module, you should be able to use the ESPT to select the minimum essential indicators needed to address priority program questions, explain how human behavior observations can help identify drivers of malaria transmission and gaps in protection, and demonstrate the importance of integrating different types of data for program decision making. Let's take a quick look at our checklist to make sure we are all prepared for this session. Please have an individual copy of the ESPT tool in front of you, either an electronic or paper copy. Please also have a notepad and writing utensil or a computer, or both, in order to take notes and participate in the exercises. We ask that you retain your program question or questions identified in Module 1 as you work through this training. Each module builds on the previous module. You may need audio earphones, functional speakers, and a stable internet connection in order to participate, depending on your training setting. We do recommend the voiceover in English if it is appropriate. And as a reminder, an orange slide refers to our illustrative example, and a gray slide refers to a participant exercise, which can be done individually or in a small group, and it is estimated to take between 10 to 20 minutes to complete. Before we get started, let's take a minute to review where we are in the ESPT. After identifying your priority program question in Module 1, we have now arrived at Module 2. Module 2 guides you through the selection of appropriate entomological and other indicators based on your program question. It is critical that programs select the appropriate indicators to answer their identified program question. Sometimes a lot of entomological data is collected but not actually used. So we want to select indicators based on the actual questions we want to answer. This training module is divided into 3 topics. Number 1, selecting minimum essential indicators, integration of data for decision making, and an overview of which vector behaviors are targeted by different interventions. There are 3 concepts that are important to know for Module 2. First, residual transmission refers to transmission that persists despite good access to and use of long-lasting insecticide-treated nets or well-implemented indoor residual spraying, or transmission that occurs in situations where long-lasting insecticide net use or indoor residual spraying are not practical. A combination of human and vector behaviors is responsible for this transmission. For example, when people visit high-risk areas or when local vectors exhibit one or more behaviors that allow them to avoid the core interventions, such as biting outside during the early evening hours when people are not under their bed nets yet. Second, human behavior observation, or what we call an HBO, which is a field method whereby collectors observe and record human behaviors related to intervention use and sleeping patterns in parallel to entomological collections. HBO data are integrated with entomological data to pinpoint human vector exposure points and gaps in protection. And lastly, a minimum essential indicator, which refers to any requisite indicator that is deemed essential to correctly measure the outcome of interest and generate actionable data for program decision making. As mentioned, malaria programs often collect a lot of entomological surveillance data that they do not use. And with limited availability of resources, it is so important to identify and collect the minimum essential data that you need to answer a program question or make a program decision. Module 2 includes 4 tables with relevant entomological surveillance, vector control, human behavior, and risk factor indicators, and we will walk through each of these tables now. Here is a snapshot of the 4 different indicator tables in Module 2. Table 1 is a list of minimum essential entomological indicators, which was adopted from the WHO Malaria Surveillance, Monitoring, and Evaluation Manual. Table 2 lists supplemental entomological indicators for programs to consider based on their relevance to decision making and the available capacity and resources. Table 3 has indicators related to vector control intervention performance and effectiveness. And lastly, Table 4 lists indicators used to measure human behavior and associated risk factors. While I will orient you to each of these tables now, we will not spend too much time on this, so I encourage you to review the tables in more detail on your own. Table 1 is a list of minimum essential entomological indicators. The first column in the table lists the entomological indicator, such as vector occurrence, density, and seasonality, as you see here. The second column, labeled outcomes, gives a description of each indicator. And the third column describes the significance of the indicator for program decision making. For example, vector occurrence refers to adult female vectors present or absent, and the significance column notes that this is important to know whether your site is receptive to malaria transmission and detect invasive species. This indicator can also be used to determine vector species composition and seasonality, and monitor the impact of vector control interventions on specific vector species. This slide shows only one section of Table 1, the section on adult vector composition and distribution indicators. However, there are 4 other sections: adult vector behavior, such as biting rates and times, adult vector insecticide resistance, immature vectors relating to larval habitat and availability, and transmission potential or receptivity. Entomological indicators are expressed by vector species, collection site, and date of collection. Keep in mind, however, that many of these indicators can also be expressed at the genus level. For example, density is ideally measured at the species level, but if you do not have the resources for species identification, density can also be measured at the genus level, that is, at the Anopheles level. Feel free to pause the video here if you wish to take a closer look at Table 1. Table 2 includes supplemental entomological indicators based on the relevance to the program question and the available capacity and resources. This table includes indicators such as human blood index, which is defined as the proportion of blood-fed adult female vectors that feed on humans out of the total fed. The comment here notes that this indicator is useful to determine anthropophagy and zoophagy of vectors and to target vector control interventions. As noted, this requires advanced laboratory capacity for blood meal analysis, such as ELISA. Other indicators in Table 2 include host preference and larval density, as seen here, as well as resistance intensity and mechanisms, and sporozoite rate, for example. Feel free to pause the video here if you wish to take a closer look at Table 2. Next, Table 3 lists indicators related to vector control intervention performance and effectiveness. Indicators in the section of the table displayed here include insecticide-treated net or long-lasting insecticide-treated net durability, access, and usage. Other indicators listed in Table 3 include intervention coverage, IRS residual efficacy, and larval source management effectiveness. Let's take a look at the first indicator here, ITN or LLIN durability. The indicator is measured by evaluating net survivorship, fabric integrity, and bioefficacy. Net durability indicators are important to monitor the effectiveness of nets over time and identify gaps in protection if nets lose physical integrity or chemical efficacy. Again, please pause the video if you wish to take a closer look at Table 3. Table 4 includes indicators used to measure human behavior and associated risk factors. Indicators in this table include parasite importation risk, identified malaria risk factors, adjusted human biting rate, and as seen here, sleeping or awake time by location. This refers to the proportion of individuals asleep versus awake, and indoors versus outside by each hour during biting times. This indicator is necessary when integrating vector behavior with human behavior to determine where and when humans are potentially exposed to mosquito bites. This indicator uses human behavior observations, or HBOs, which we will describe in more detail on the following slide. Feel free to pause the video now if you want to take a closer look at any of the four indicator tables. One of the key concepts in this module is human behavior observation, or HBO. Human behavior is an integral component of entomological surveillance, and thus the ESPT tool. The objective of HBOs is to understand how human behavior overlaps with vector behavior to identify where and when humans are exposed to vectors. These times and places can then be specifically targeted with vector control interventions. HBOs can help identify gaps in protection, local drivers of transmission, and the characteristics of residual transmission. The specific human behaviors that can be measured using the HBO method include sleeping and waking times, times and duration spent outdoors versus indoors, use of and adherence to vector control interventions such as nets, changes in behaviors relating to the season or religious traditions, for example, and mobility patterns. Surveys or interviews can also be conducted to supplement HBOs to understand user experience and acceptability. Human behavior observations can be conducted during entomological collections, such as human learning catches or HLCs. Here you can see two HLC collectors, one inside the house and one outside the house, and both are busy collecting mosquitoes that land on their legs. It is 9:40 p.m., which is the fourth collection hour of the HLC collection night. Now it is 9:50 p.m. and the HLC collector inside the house stops collecting mosquitoes and starts counting the number of individuals inside the house, and of those individuals, the number who are awake versus asleep, and the number who are under a bed net versus not under a bed net. The HLC collector outside the house does the same. Near the end of each hour, the collector stops collecting mosquitoes and instead observes and records the number of people outside, the number of people asleep versus awake, and the number who are under versus not under a bed net. Each HLC collector should observe and record these human behaviors at the end of every HLC collection hour. It does not take much time, and a simple form can be used to record the hourly observations. Annex 4 in the ESPT includes a template to record HBO data. This form should be completed alongside HLC collections by the supervisor or by the HLC collectors themselves. Each row corresponds to an HLC collection hour and should be filled out at the end of each hour. As you can see, this form captures the location and behavioral category of individuals by collection hour. Combined with an appropriate method to determine biting times and locations, such as HLCs, HBOs can capture data needed to identify when and where humans are exposed to mosquitoes and where there are gaps in protection. That said, this form is a template and modification might be necessary to suit the program needs and the current interventions in place. Our second topic to review in Module 2 is the integration of data for decision making. As you know, analyzing entomological data alone will rarely tell the whole story, and the same can be said for epidemiological data. Entomological and epidemiological data alone only tell half the story. Therefore, this data should be integrated and analyzed together to identify relationships and trends and to inform intervention selection and targeting. The ESPT provides guidance on the integration of entomological data with epidemiological, human behavior, and other key data. In addition to entomological and epidemiological surveillance data, the ESPT identifies some key datasets that should be considered for integration for optimal program decision making. These data sets include rainfall and climate data, vector control intervention data such as intervention access, use, and acceptability, human behavior observation data or HBOs, operational inefficiencies such as stockouts of malaria diagnosis and treatment supplies, and changes in receptivity or importation risk, which could include population mobility or new construction sites. It is important to recognize that all these factors can be considered possible drivers of transmission and should be included in any analysis and interpretation of entomological data. The decision trees in Module 7, 8, and 9 provide some examples of how the data integration can be done. Vector control interventions target specific vector behaviors. This means that interventions only protect people from being bitten when human behavior and the specific vector behavior targeted by the intervention overlap. For example, bed nets target mosquitoes that bite people at night while they are asleep. Therefore, bed nets are only effective when vectors do bite at night, when people are sleeping, and when people are using their bed nets. In order to assess how effective current interventions are and to identify remaining gaps in protection, human behavior data must be integrated with vector behavior data. This is done by integrating the human biting rate, HBR, inside and outside the house with the proportions of people doing specific activities inside and outside the house. For example, sleeping under a bed net or socializing outside. This data is collected through HBOs. When you combine the HBR data and the human behavior observation data, you obtain the adjusted biting rate for each activity. Here, the people socializing outside during the mosquito biting hours represent a gap in protection. Our third and final topic of Module 3 is vector behaviors targeted by interventions. To select the most appropriate indicators to answer priority program questions, it is important to understand how vector control interventions target different vector behaviors. Table 5 in the ESPT identifies the specific vector behaviors targeted by different vector control interventions. For example, we can see here that IRS targets insecticide-susceptible indoor resting vectors, whereas attractive targeted sugar beets target sugar-seeking vectors. Understanding the Anopheles mosquito's life cycle and the specific points where vector control tools intervene to kill or repel mosquitoes is important to understand how malaria interventions function. Figure 2 in the ESPT shows the Anopheles life cycle and pinpoints where the different vector control tools intervene. For example, interventions like special repellents and space spraying specifically target host-seeking mosquitoes and mosquitoes that have already blood-fed and are resting. I encourage you to take a closer look at Table 5 and Figure 2 in your copy of the ESPT. You may choose to pause the video at this time if you wish. This brings us to Table 6. Table 6 displays the minimum indicators needed to determine whether a new intervention should be introduced. Different vector control interventions are along the top row, and the minimum essential entomological indicators and the supplemental indicators are in the first column. If an indicator is required for a certain intervention type, the box will be shaded teal. If the box is shaded light purple or gray, the indicators may be required for that intervention, but it depends on other factors. The darker purple or gray shaded cells refer to resistance to larvicides for the larval source management column specifically. Let's take a look at long-lasting insecticide-treated nets as an example. Here we see long-lasting insecticide-treated nets in the first cell in the top row. And looking down to the indicator column, we see all the indicators that should be collected in order to determine whether long-lasting insecticide-treated nets should be introduced as a new intervention in a certain area. We can see that vector occurrence, vector density, human biting rate, biting time, biting location, resistance frequency, and resistance status, and human sleeping time and human sleeping location are recommended indicators here. Remember that the number of indicators you collect will also depend on the capacity and resources available. Similar to Table 6, Table 7 displays the minimum indicators needed to determine whether an existing intervention is working effectively in a certain area. This table is formatted in the same way as Table 6. It lists the different vector control interventions on the top row and the minimum essential entomological indicators and the supplemental indicators in the first column. The teal shaded cells indicate that the indicator should be collected. While this table may appear overwhelming, some sampling methods capture data for more than one indicator at a time, which will be explored further under Module 3. Let's return to our example. Recall that in Module 1, we identified our priority program question. Are bed nets an appropriate intervention for the village community of Katosha? Now let's do some initial brainstorming around minimum essential indicators for this program question. First, what vector behaviors do bed nets target? How are humans protected from mosquitoes by bed nets? Which vector, human behavior, and intervention indicators can help assess the appropriateness of bed nets in Katosha? Please pause the video to review indicator tables 1 through 4 in the ESPT now, including the significance column. Then come up with some answers to the initial brainstorming questions. Great, now let's walk through these initial brainstorming questions together. What vector behaviors do bed nets target? As we can see in Table 5 in the ESPT, bed nets target mosquitoes that bite during the night inside houses. Our second brainstorming question, how are humans protected from mosquitoes by bed nets? Humans are protected when they are sleeping under the bed net. When they are outside of the bed net, they are no longer protected. And now back to our third brainstorming question, which vector, human behavior, and intervention indicators can help assess the appropriateness of bed nets in Katosha? For essential vector or entomological indicators, refer to tables 1 and 2. Here we identify vector occurrence, vector density, seasonality, human biting rate, biting time, biting location, and resistance frequency and status. For Table 2 on supplemental entomological indicators, we have decided that we do not need any additional indicators from the list. For Table 3, we may select long-lasting insecticide-treated net access, long-lasting insecticide net usage, and the long-lasting insecticide net use to access ratio. And in Table 4 on human behavior and risk factor indicators, we might select human sleeping and awake times by location, adjusted human biting rate, malaria risk factors, and key populations at risk, for example. After identifying the desired indicators, you can review Table 6 to better understand which are the minimum essential indicators for this investigation, and then narrow down indicators based on available resources and capacity. When we review Table 6, specifically the long-lasting insecticide net column, we see vector occurrence, density, human biting rate, biting time and location, resistance frequency and resistance status, and human sleeping time and location as supplemental indicators. Based on the table, we can remove some indicators from our list: long-lasting insecticide net access, long-lasting insecticide net use, long-lasting insecticide use access ratio, as well as malaria risk factors and key populations at risk. Also note that by collecting the human biting rate, or HBR, we will automatically collect vector occurrence, vector density, and vector seasonality data. So we will also have these indicators. Now it is your turn to select indicators for the priority program question that you identified in Module 1. Follow the workflow outlined here, but please take your time and refer to your ESPT often. First, brainstorm what information you need to answer your program question. Consider both vector and human behaviors and existing data sources. Second, review tables 1 to 4, including the significance column, to list appropriate indicators based on your question. Also review Table 5 and Figure 2 as needed. Third, review Table 6 or Table 7 if applicable to your question and refine your list of indicators accordingly. Think through what other information or data may help to answer the program question. Fourth, are there other types of data that can be integrated with the selected indicators to better understand and address the program question? And finally, further refine your list of minimum essential indicators. This will be used throughout the training to inform selection of sampling methods, design, etc., etc. Well done. This completes Module 2 and Unit 1 of the ESPT training. At this stage, you should be able to identify and formulate a programmatically relevant question and select appropriate entomological and other indicators to answer the program question. The next module, Module 3, will cover sampling methods. On behalf of UCSF's Malaria Elimination Initiative, thank you for listening, and we hope that this was a productive session.